Hello and welcome to CS230. This is lecture 14 and lesson 2. And in this particular lesson I'm going to give you a brief overview of developing the ER model for our customers and addresses database. We'll develop this database, a physical database, a little bit later in lesson 3, and in lesson 4 we look at how we can query and manipulate that database using PHP, and in lesson 5 we'll look at how we might do the same kind of work with Node.js. Right, so we're in the last lesson, we looked at the key terminology. So we learned about entities, we learned about attributes, and we learned about keys. But I mentioned relationships and weak and dependent entities as part of that discussion. We didn't really go into it in any detail. So before we look at the actual ERD, the logical ERD that we're going to be working for our example database, we need to actually think and talk a little bit about relationships and cardinality. So relationships illustrate the association between two entities, and they're usually represented with some kind of straight line. And we can see an example of one down here in this particular diagram here. So we have an entity A, we have an entity B, and we have some kind of relationship. And remember that entities are kind of described as the nouns of the system, and the relationships refer to the verbs in the system. So the actual ERD shows a third thing, okay, and it shows a cardinality rule. And these cardinality rules define the allowable counts of the relationships. For example, is the relationship between the entities one-to-one, one-to-many, many-to-many, etc. So diagrammatically, we tend to show that using two indicators. Okay, one that refers to the maximum cardinality, and we see something here, the maximum cardinality, and one that refers to the minimum cardinality. So the maximum cardinality is often referred to as multiplicity. And if you're reading the textbooks, and if you're looking at textbooks again, you'll see sometimes they refer to minimum cardinality as ordinality, optionality, or modality. And that's first of all, the maximum cardinality, that describes the maximum number of times that an instance of one entity can relate to an instance of another entity. Okay, and then the minimum cardinality is the minimum number of times one instance of an entity can be associated with an instance of the related entity, and that can be 0 or 1. So that's why it's often referred to as an optional or mandatory. And so the combination of the two then is always in a specific order. Okay, so placed on the outside edge of the relationship, the symbol of the cardinality becomes first. You see here on the outside edge of this connection, and then the symbol indicating whether the ordinality or the relationship is shown after the cardinality symbol, and you can see that here in here. Okay, so there are lots of ways of defining this is called a notation for describing the relationships, and there are many forms of that notation, for example. So there's the Chen notation, the original 1970s one, the UML, Unified Modeling Language, the Barker, the Arrow, the Crow's Foot, and IDEF1X notations. Okay, so but it doesn't matter which notation you use. So like something you'll see dots here, you'll see your relationship as a diamond, you'll see all of these things, okay? And it doesn't really matter. Okay, what matters for us is that there are 4 possible edges to the relationship. There's going to be a 0 or many, a 1 or many, a 1 and only 1, and a 0 or 1. And for my ERDs, well, in these lessons anyway, I'm going to be using the crow's foot notation to express the relationships, as shown in this particular diagram here. So a multiplicity of 1 and the mandatory relationship is represented by a straight line perpendicular to the relationship line. And the multiplicity of many is represented by the 3-pronged crow's foot symbol. Okay, so here's the crow's foot, and here's the line. Okay, multiplicity of 1. An optional representation is represented by this circle here. So I've shown the way we draw the maximum and the minimum cardinalities for each of them, and the grey is just, that's just to highlight the parts that we're interested in looking at. Okay, so in that case, then we have 3 common cardinal relationships. They're one-to-one, one-to-many, and many-to-many. But here's an example using crow's foot. So here's a one-to-one. So a student may have one locker. Every student has one locker, and one locker is associated with one student, for example. A lecturer may give and have many courses, and a student may have and use and attend many courses. Okay, so we're interested in our customer address, developing our customer address ERD. Okay, so some background for this. Okay, so once we have the basics for creating these ERDs, we can think about this customer address database. And I'm going to use a really brilliant example from a series of posts that were from about 4 years ago in the maybe longer now, okay, in the database administrators Stack Overflow site. And if you're interested in databases, this is a great place to be. I mean, you've been there for JavaScript, I know, and PHP and so forth, okay, and it's from some unknown user. We don't know who that person is, but they And this is the link to their profile. Okay, it's really excellent reading, and I'd recommend it. It summarizes, you could read lots and lots of books, but I'm, have to be a bit mercenary in this particular module. We can't go over everything from the beginning. Okay, so anyway, they use and the one thing to note though is that the author indicates that they use a specific notation, the IDF1X standard, to generate their diagrams. Okay, and in this particular diagram, weak or dependent entities are represented by round corners under rectangles, and we saw that in the previous lesson. And strong entities are just represented by a rectangle. Okay, and then this entity is normally divided into two parts: the upper part that gives you the primary key attributes, and the lower part contains all the rest of the attributes. Okay, and the name of the entity is usually associated above the attributes. Okay. Above the entity itself. Okay, foreign keys are labeled as FK, alternate keys are represented as AK, and PK represents the primary key field. Okay, now the actual standard for IDEF1X actually uses solid and dashed lines with filled circles at one of both ends. It doesn't usually use crow's feet. Okay, but the example that's used in these particular posts use crow's feet, but that's okay. Okay, so it's a different kind of notation. Okay, but there's a nice cheat sheet for IDEF1X here. You can click through and get to that. And I'm going to be working with a limited number of entities from the example. Okay, so this is the one we're interested in developing. You'll notice that here's this dependent or weak entity here. It relies on the existence of a customer address before we can assign the two. Nice round corners, square corners for entities. I'm using crow's feet notation for the cardinality rules, and we name the actual relationships. But this doesn't come from nowhere. Okay, so we have some rules. So we have a logical layout here that comes from essentially our conceptual model, and so it tells us that we need to have one table to keep the address information, one table to retain the customer specific details, and one table to contain the facts about the customers and their addresses. So for the relationship or the association between customer and address, there's a many-to-many cardinality ratio, many-to-many, because a customer might keep multiple addresses over time or even simultaneously, and the same address could be shared by multiple customers. Okay, right. So you have to provide you might also have a specific address to be used in several ways. For example, you might have an address defined as physical. Okay, that is their physical address. Then it can be set for shipping or billing, or perhaps you might have an alternate address for shipping and billing. So we need to be able to handle that kind of stuff. Here's the wiki: is physical, is shipping, is billing, and is this address active? And it's useful. So the relationship between the customer and their address may change over time. So you actually require to have an auditable entity type. Okay, that maintains a customer address history. So we're able to look at this. So it allows things to change over time, and this tells us when this particular instance was created. Okay, so it's a very useful approach to doing and making our design. We have some logical rules, essentially coming from our conceptual model. They make it into the logical ERD here, and then we'll make a physical ERD in the next exercise. Okay, so look, there's some good resources on this topic. So if you want to look at the different notations for cardinality, you got to look at this Medium article or this Vertebello article, and these are the Stack Overflow posts for the that I mentioned earlier. Okay, that refer to storing a billing address and best practice and so forth. Okay, so we quickly reviewed ER modeling, that's the relationships, the cardinality notation. We saw then how we can put these together to produce an ERD model for our customer address database, and that's based on some business logic rules. And the next lesson now will give an overview of how I created the physical relational database for this design. Thank you very much for watching.